Hello and welcome back. I wanted to take this time to go through what port channels are on Nexus devices, what we can use protocol-wise to create port channels, and how that configuration actually looks and how we verify it within our switches. Now, if you haven't been through some of the earlier videos, I just want to briefly go over what a port channel is, because a lot of people are probably like, what's he talking about here? So let me just kind of break it down for you. Port channels are a way we can logically bind two physical or more interfaces together to form one logical interface. Now, I may have said that wrong, so let's draw it out. Say we have two switches. And we have two links in between them. By default, what's spanning tree going to do here, guys? Spanning tree is going to come in and it's going to block one of these links, so we can't even use it, right? We could go in and we could load balance some of our VLANs using spanning tree parameters and kind of just determine which VLANs are blocking on which links. But really, we're not getting the full benefit of having two links in between these switches because one is blocking to prevent that layer 2 loop from forming. So what we can do here is that we can take these two ports on each of these switches and we can bond them together, and it's usually, you'll see it annotated on most network diagrams to look like this with a little circle around the two links. That is a port channel. Okay, so what does a port channel do in terms of spanning tree that would cause it not to block this link? Well, what it does is it actually forms or presents this to spanning tree like this is one big pipe. Okay? So spanning tree is now seeing these two physical links as one link. This is awesome, right? Because now we're not blocking on that link because we don't have a loop, right? Because it's just one link between the two switches. So this allows us to have more bandwidth and a little faster failover if one of these links were to maybe die or be unplugged, because no spanning tree recalculations would have to happen. We just immediately start forwarding on that other link. Another thing we need to think about, though, is, well, how does traffic flow along a port channel? How does it determine which physical link is being used? Does it take maybe one TCP flow and load balance it among the two links? And the answer is no. What it does is it does something we call results-based hashing, or RBH. So each switch and different platforms have different default hashing algorithms, but they'll usually hash something like source destination IP, source MAC address, and that's keeping it simple. They can look at some layer 4 and above headers, but just on a real simple basis, they'll look at like MAC addresses or IP addresses and determine which physical link a given flow is going to take. Now, the key here is that a given flow is always going to take the same link. Now, we may have a PC over here wanting to talk to a server over here, and say it starts a flow. This switch is going to hash that flow, and maybe it picks this bottom link to send it on. Okay? And it comes in on this bottom link and is passed over to that server. Now we come back in, and say we have the server who's wanting to talk back to that client, and it comes in with a flow. And this switch does a hash, and maybe its hash says it's going to use the top link. Okay, so it uses this top link, and it comes back to the client. Now that's perfectly acceptable, but just know that any given flow in one direction is always going to take the same link. And that's maybe a little advanced for the CCNA, but I think it's good to know. It's good to convey to you guys early on, so when that concept is smacked on you at the CCNP level, you're like, oh yeah, I kind of remember Jason talking about that earlier in my CCNA studies. So this RBH is just a good, important concept just to at least have some base knowledge on. And now you do. So when we form this port channel, we have a couple options at how we can do this, okay? So within NXOS, we have port channel mode on, which up here is also known as a static port channel. And we have LACP, or Link Aggregation Control Protocol. This is also known as 802.3 AD. This is going to be one of those numbers that sticks with you throughout your career if you haven't seen it already. So LACP is actually a protocol that's running that actually they negotiate to form the port channel, rather than when you configure a static port channel, you're just saying, this is a port channel, I don't care what the other end's doing. So as you could probably see, one of the main benefits to LACP is that in a lot of terms and a lot of conditions, it's a little bit safer to do and to implement, because you're not going to form that port channel unless both ends can agree on the port channel, okay? So I always personally do LACP where I have the chance and where it's applicable. I do static only if it's like a server or some kind of system that can't do a port channel, and then there's a lot of verification involved to make sure that port channel forms successfully on both sides, that we're not doing some kind of accidental looping by doing that static port channel. Now, if you're looking at me funny because I'm not mentioning something, you're absolutely correct. There used to be a protocol called Pagp or Pagp, Port Aggregation Protocol from Cisco. They have deprecated this, and it's not actually included in Cisco's NXOS. Why is that, you say? Well, because LACP is a ratified protocol, and Pagp, as we all know, was a Cisco proprietary protocol. Well, in any data center now, we have, it's a multi-vendor environment, right? We're interfacing with VMware, we're interfacing with different servers, different systems, so they moved to really a more IEEE-centric model for these data center switches, in that they removed a lot of the proprietary stuff, and a lot of the proprietary stuff we're used to, like EIGRP, which is now getting ratified, is still included. But Pagp is not in the mix anymore, so we don't have to worry about it. Now with LACP, we have a couple of these different modes that a lot of you probably heard of and some of you probably haven't, so I'm going to mention them now. Those two modes with LACP are active and passive. Okay, so let's draw a little chart here, because we can put active or passive basically on either end of a link, right? So let's go in here and we'll call this passive. This will be active. So say this bottom is link 1 and this side is link 2. So say we have active and passive on two ends of a link, we will form a port channel. Say we have active and active on two sides of a link, we will form a port channel. Now if we have passive and passive on two ends of each link, or on each end of a link, we will not form a port channel. But again, if we have passive and active, we will. So what does this signify? Basically, active is actively trying to negotiate the LACP port channel with the other end of the link. Passive will never initiate the communications, but it will accept it if the other side is active. So we need to either make sure that one end is active or both ends are active for the port channel to form. And I'm going to show you guys this on the CLI and how to verify that. I also briefly want to mention compatibility parameters, which are important within port channels because we need to make sure that the ports are similar enough to bond together into a port channel. Because we wouldn't very well want to bond together maybe a trunk and an access port, right? That just wouldn't make any sense because they don't do the same thing. So we have these compatibility parameters, and then look, the list gets quite extensive. If we go into the NXOS CLI and say show port channel compatibility parameters, you're going to get this really long list that you actually have to sit there and spacebar through, and it's no fun to look at. But we'll go over the heavy hitters here so that you guys know what they are. When we talk about compatibility parameters, we need to be cognizant of the link speed. The speeds need to be the same on all the links in the bundle. So we'll say speeds. Also, when we think speed, we immediately should transition and think duplex. So our duplexes need to be the same as well. Our port mode is also another biggie. So our mode, now what are those modes again? Access, trunk. Okay, so we also need to make sure, like, if we're a trunk port, that our allowed VLAN list is the same, that our native VLANs are the same, and if we're an access port, we need to make sure that our access VLAN is the same as well. So those are really the heavy hitters that I want you guys to be aware of. And when we go in there, I'll show you guys what happens when maybe we mismatch a speed Will it tell us that we've mismatched that speed? And indeed, it will tell us that we mismatched a speed or a duplex or what have you. But these need to be in the back of your mind anytime you start thinking about port channels, because we need to have similar ports to actually group into these port channels. And finally, verification. Guys, I'm big on verification because there's usually always a way to verify your configuration in the CLI. Now, what we'll be able to do is go in here and check our port channel configuration by saying show port channel summary. And we'll also be able to go into spanning tree, right? Because in spanning tree, instead of seeing those individual links, we should be able to go in and see that the spanning tree is just seeing the logical port channel interface rather than the physical interfaces. So with the demo I'm going to give you guys, we're going to have those two 5Ks again. So what we have between those is 4 links. 5, 6, 7, and 8. I want to show you guys the 2 different modes that we can use. So on these top 2, I'll do on. On these bottom 2, we'll do LACP active and passive. And then on this guy, we'll do on. Because I really want you guys to be aware of how this looks and how the configuration looks at a really basic level so that you have a good understanding of the technology. So let's zoom on over here. And I'll pull up the command line interface. So this is our 5Ks. Let me log in here. And if I no shut these, I should be able to say show CDP neighbor, and I should see my peer out those 4 ports, and I do. So as I mentioned earlier, what we want to do is go in here and configure 5 and 6 for mode on, and we'll do that first on both sides so that you guys can see it. So to show you guys these compatibility parameters, I'm going to change the speed on port 5 and try to bond these 2 together. So I'll say int e 1/5, we'll say speed 1000, and now I'm going to go into interface range command, but we don't need to use range in NXOS. We can just say int e 1/5 through 6. Now I'll say channel group, which is actually the command I'm saying I'm going to port channel these together, and then I need to give it some kind of number. As you can see, I can give it any number between 1 and 4096. I'm just going to call this port channel 1. And it gives me a command failed. So I have a command failed here. Port is not compatible. Your speed is wrong. So I personally, at this point, if I was troubleshooting, I'd say show interface status. And I would see what's going on. So I can see here that all these are 10 gig speeds, and then 5 is 1000. So I know automatically that I need to change my speed or some configuration is wrong on port 5. So I'll say show run int e 1/5 up, and sure enough, there's that speed 1000 I need to get rid of. So I'll say no, I'm still in interface range mode, so my commands are still applicable to port 5. I'll say no speed 1000. And then I'll just up arrow twice or 3 times and say channel group 1. And now I can see my port mode is wrong. Well, what is going on here? So I can see that this one is a trunk, which is correct. Oh, and this one's still our default access port. So let's say switch mode trunk to both of those ports and then channel group 1. Now it takes the command just fine. So now I want to go to the other side, and I'm going to do the same thing. I'm going to go into int e 1/5 through 6. I'm going to say switch mode trunk first, right? Because we want this to be a trunk. And then we'll say channel group 1 and no shut. So now when we look at our configuration, what we should see is it created a logical port channel interface for us that is now a trunk. So I should be able to say show run int port channel 1, and now I see that I have a port channel interface that was dynamically created for us in trunking mode. Very important. So to verify this, we have two commands that I want to show you guys. The first one is probably my favorite port channel verification command, and that is show port-channel summary. Now when I look at this, I get this big chunk of output here, and let's go through it. So I see that I have channel group 1, which is port channel 1. Then I have this SU. What does that SU mean? Well, if we look up here, it means switched and that the port channel is up. That's a good thing. So this is an Ethernet port channel. I'm not using a protocol, and my member ports are 1.5 and 1.6. Also note this P, which means the port is up in the port channel, and that's what we should see in these parentheses on both sides. So it looks good. Let's also check our spanning tree config. Show span, let's just do VLAN 1. This is exactly what we want to see here, guys. These other two ports that we have physically between these two switches are shown individually, whereas 5 and 6 have been removed, and now we see port channel 1. So this is the second verification command that we have to see if this is actually working as intended, and it is on this side. So we created this port channel over here too, and maybe we want to check and make sure that all our running config is intact. There's actually a really nice command within NXOS now where we can say show run int port channel 1 membership. The keyword here being membership. What this is going to do is show us the running config of the port channel and any associated physical interfaces that are bound to that port channel. So here we can see that they all look very similar, and we see our channel group 1 command here. So let's do our verification. Show port channel summary. Looks good. Switched up. Both are P or passive up in the port channel. We'll say show span VLAN 1. And we see port channel 1 there, and 5 and 6 are omitted, which is great. So we're looking good here, guys. We've created our first port channel. So what has this done in terms of bandwidth for us? How do we verify, what the bandwidth is on any given port? We do a show interface command. So if we say show int PO1, we can see this is running full gig or full duplex, 10 gig speed, but our bandwidth is 20 gig because it's the combined bandwidth of those two interfaces that we have on there. So this is awesome. Now we've got 20 gig port channel between these two switches, but we're running static. So we don't have that fail-safe mechanism of that protocol negotiating the channel for us. We're just statically creating the port channel on both sides. So what we want to do next is go in here and configure LACP and see how it looks with our verification commands. So we're going to do ports 7 and 8 in LACP. So let's go into that range. Switch mode trunk. Now we're going to say channel group 2, but instead of hitting enter here for static port channel, we're going to say mode, and we said on 2 we would do active. So we're going to do active. Notice on is the default if we just hit enter after channel group 2, but we can also do mode on to do static port channels as well. But to do LACP, we're either going to use active or passive. So on this side we'll use active. We forgot to do something. LACP process needs to be started before we can configure this. So we need to go in and say feature LACP. We'll go back into our interface mode, and we'll say channel group 2 mode active and see if it takes it this time. And it does. So now let's go to our other side, and we'll do the same thing. We'll say feature LACP interface Ethernet 1/7 through 8. We'll say channel group switch mode trunk, right? And then we'll say channel group 2 mode passive. And it took it. So now we need to go in and do our verification commands to make sure that we have actually formed a port channel using LACP. So let's say show port channel summary. Accidentally did M there. Now we can see that we have a second port channel interface that is up with both links up in the port channel, and notice what we see here. LACP is now under our protocol rather than none. This means that we have dynamically formed a port channel using LACP between these two switches. So let's verify on the other side. And again, we have verified that we have an up and up port channel. So let's check spanning tree from this end and say show span VLAN1. Notice before where we were showing the port channel and the two individual interfaces, now we are showing two port channels. So we don't even have that individual interface. But since we have basically two 20 gig port channels in between that switch, in this specific case, it still leads us to a situation where we have two big port channels, but one of them is blocking the spanning tree. But in essence, I've shown you what I meant to show you. What I intended to show you is that there's two different ways to form port channels within NXOS, one using LACP and one using a static mode of on. They're both super easy to configure, and it should be nothing you should be scared of, so you should be ready to slay any questions they throw at you in terms of port channels on the CCNA exam. Next time we're going to start talking about layer 3 and a lot of routing stuff, so I look forward to seeing you in the next video. Thanks.